All right, so what controls the temperature? And we've already talked about latitude and the sun being spread out along the ground, so go back to a previous video if you forgot about that. Then there's also differential heating of land and water. We'll talk about that. Ocean currents, altitude, geographic position, cloud cover, and albedo. So, differential heating of the land and water. This is a great picture because you can see California is super duper hot, right? I mean, it's red hot, right? And then the water right next to it, not so hot, right? And this is because land heats up faster than water, land cools down faster than water, okay? Why that is, there's a couple things. Water can move. Heat in water is transferred by convection. Heat rises, cool sinks, right? Convection, it can move. Land, in case you haven't noticed, can't move. So the heat transfer is done by conduction, right? That's the one molecule gets speeded up really fast and slams into the other molecule, right? Conduction. So that takes a little longer, and this video will kind of show you that. Okay, so right there, you've got the blue and the green. The green is doing conduction, so it's sinking to the bottom and it's kind of letting it rise, bumping into molecule by molecule. It's water, so it's not perfect, but you get the idea. And then this is convection, just letting it sink and swirl, okay? I'm going to come back to these, but watch them. You can see the swirling of the water. It's instantaneously blue. Here, you still got some white. It hasn't quite made it up there yet. Right? So this one, really fast. This one, really slow. Let's watch that again. Here we go. Blue. Everything's blue. Here, I think everything's green now, right? Look how faint that is. Like, I think that's all green. Blue, right? Conduction versus convection. Convection is way, way faster. Another reason, you can't see through land. I know you're shocked, right? But that also means the sun can't see through land. So it gets to heat up that top layer, right? So if you go to the beach and you dig your feet into the sand, A, your feet disappear, and B, you get cold, right? You get that cold sand right underneath that top little layer. There's that cold sand, right? Water, sun can go right through the water, so it heats it up more evenly. Another big reason is that there's more heat, more energy, right? Heat is energy. More heat required to heat up one drop of water than one grain of sand. Ocean currents have a big play, right? Here you can see the nice warm ocean. It circles into the ocean in the Gulf and then comes out into the Gulf Stream, and it carries heat up north, right? That's what it does. It moves heat up north. And you can see this in the circulations. All the red ones are going towards the poles, north or south, whichever one you live in, right? It's going towards the poles, and all the cold stuff is coming to the equator, okay? Just because we live in Tampa here, and the hurricane comes along, right? It moves up to the poles, and the cold comes down to the equator. Here, going down to the poles, up to the equator. Down to the poles, up to the equator. Up to the poles, down to the equator. Altitude. Altitude is a great one. And we don't really have to worry about that here in Florida, but other places do. This is a picture of Denver in, I want to say June. Okay? And green, luscious, warm down in Denver. You can see the mountains in the back, right? And they've got this white stuff. For us Floridians, it's called snow. And it only happens when it's cold, right? So here you have nice, lush, foresty land. Here you have snow, And this is great because my husband went to Denver for a conference before we lived there, and he didn't know about mountains having this drastic change. And so they're like, hey, let's rent a car. And this was in August. Like, hey, let's rent a car and go up Mount Evans, which they call 14er because it's 14,000 feet above sea level. Right, so cold. And they didn't know about that. So they rented a car, flip-flops, t-shirt, shorts. They go up to the mountain, and you can drive up the mountain, and they get out. Oh my goodness, they were in for a surprise there. Snow on the ground. So they're in flip-flops in snow. That's not fun, people. Right? So I have a picture of them freezing in their shorts and t-shirts and flip-flops in the snow. It's hilarious. I'm like, didn't you know? Like, didn't you look up and go, oh, there's snow there. Maybe we shouldn't go there in flip-flops? But no. Geographical position. Where are you? Right? Being by water is great. It keeps you more temperate. Right? Now, but where by water? Because look at Eureka over in California. Look at New York. Same latitude. Right? Well, Eureka is the red one. Very, very temperate. Right? I mean, 45 to 55, like 10-degree difference for the whole year. Why? Because they're right next to the water. The wind is coming this way, and it's blowing that temperature right into Eureka. Now, in America, our winds go like this. So on this side, you have New York getting all of this air. Well, all of this air comes from the rest of the country, which is land. So they're getting that heat up real fast, cool down real fast. And you can see that in the wintertime, right? You're looking under 30 to above 70. Yeah, that's a bit of a range, right? We talked temperature range before. Now, Seattle and Spokane, same state. They're both on the west side. Seattle is close to the water. I mean, it's a water town. However, it's not on the water like Eureka, right? So it's still water, but you can see there's still a little bit of variant here. Now Spokane, big variant. Why? Because it goes over the mountains. Albedo. Gotta love albedo. Okay, so cloud cover. Clouds have a high albedo. They reflect the heat back. Okay, so in this case, there are no clouds. Nothing blocking the way. So the heat comes in, the heat goes out. And some of you might be like, look, there's clouds right there. See it over in the distance behind the mountains? There's your keywords, behind the mountains. So here, there's no clouds. And this is like Havasu, Arizona. This is actually the original London Bridge. So it didn't fall down. They just moved it to Arizona. And it is hot here. Dry heat, wet heat, I don't care. Once you get to 104, it's hot. Okay? So during the day, 104. We'll just go with that. It gets hotter, but we'll just go with that, right? 104. So you can be out there sweating. Here, took us off. And then at nighttime, drops down to like 40. Okay, 40? Yeah, 40. Like where you have to wear a sweatshirt, right? And a jacket, like 40. So during the day, you are sweating like nobody's business. And at night, you have to put a sweatshirt on to walk your dog. This lovely town here, this is called Detroit. And you can see everything is gray. That's because we get all cloud cover. So we get clouds here all the time, and it's just blankets of clouds with no break, no sun, right? The people that live here are like, sun? Oh, is that little dot that's trying to come through? That's it, right? And everything just looks great. But on the bright side, there's no temperature change. Because the clouds are not allowing any sunlight in, the temperature does not rise during the day. But also because the clouds are not letting any of the heat radiate back out, there's no cooling down at night. So you wake up and it's 65, you go to bed and it's 65. You wake up the next day, it's 65, you go to bed and it's 65. You wake up and it's still 65. And this goes on for days and days and days and days. Snow and ice also have a huge albedo, right? Very, very reflective, very, very pretty. That's probably why they're so pretty, because they're so reflective. However, it keeps it colder, right? So the sun comes in and tries to melt the snow. Well, it has to be cold in order for it to snow. So then the sun comes, so it's cold, it snows, sun comes, tries to melt the snow, can't do it because it reflects it back up rather than absorbing it and allowing it to melt. This is why inside an igloo actually works, because you have your heat inside the igloo that can't escape because it hits that ice wall or snow wall and it reflects back in.